This one could be a battle. This is a Proton D1200 amplifier, and it's in need of some serious help. I can't even power it up safely, so let's remove some covers and take a look around. Here's the bottom of the amplifier. This is where all the action is. Let's take a closer look at the problem area up here. This is all from the right channel. You can see all four of these transistors were absolutely smoked. This one's leg was blown completely off. I've been told that this occurred when performing the idle current or bias adjustment procedure, so we'll just have to keep that in mind. The goal here will be to identify all of the failed components. Some will be obvious like these, and there'll probably be some other ones that aren't so obvious. Identify and order replacement components, get those installed, and test the unit to verify it's functional and robust once again. So let's head to the schematic. Here's the schematic for the right channel. I've highlighted all 5 components that have obviously failed. Here are the 4 transistors mentioned, and also the bias transistor is missing a leg as well. Now I'll go through the entire amplifier. I'll inspect every single one of these semiconductors and resistors, and I'll mark up this schematic with any that are marginal or completely failed so I can build a parts list. I'm all done. Let's review the full set of failed components. We already knew about these 4 transistors. These 2 are the outputs on the positive side. These 2, I believe, are part of the dynamic power on demand circuit. The 4 matching transistors on the negative side also failed. The output drive transistors for both the positive and negative side failed. We already knew about the failed idle current or bias transistor. This fusible resistor, 750 ohms, failed. And although it's measuring okay, as is typical, I will also replace the idle current adjustment potentiometer. Here are the components I'll use. I'll put the full parts list in the description. Time to get to work. All components have been replaced. I also replaced the left channel's idle current potentiometer. Now it's time for the fun part. Power it up. That's fantastic. Powered up okay. Came out of protection in somewhere around 5 seconds. That's what I'd expect. And look at those meters, huh? They don't show up very well on the camera, but they do look very nice in person. Let's move on to idle current. Sometimes there's no convenient point for you to attach your test probes when adjusting the idle current, so you have to make your own convenient point, as I have here. Per the service manual, we're looking for 2.5 to 5 millivolts across the emitter resistors. I'm going to shoot for 3. We have the left channel on this left meter and right channel on the right. Let's go. Left channel's perfect. I'll move on to the right. Perfect. Next, I'll calibrate the power meters. There's no procedure in the service manual, so I'll use 50 watts. There's 2 potentiometers for adjustment right here. We'll start with the left channel. And now the right. Now let's see how the meters move together. Nice and smooth. Now let's take a look at the signal integrity from both channels. This is 100 Hertz. Both channels are nice and clean and even. This is 1 kilohertz or 1000 Hertz. Still looking good. 10 kilohertz. And 20 kilohertz. No problems. How about output power? This amp is rated for 100 watts into 8 ohms. It can certainly handle higher power, but only for very short bursts of time. So I'm just going to check at 100 watts. Into 8 ohms, that's going to be 80 volts peak to peak. At 20 volts per division, we need to hit 4 divisions. Let's see if we can get there. It's about right there. That's 100 watts. Fantastic. I've been listening to this amp for the last hour or so, and it's sounding fantastic, so I'm all done here. I'll leave you with a little power meter deflection from a copyrighted song. Thanks for watching.